So the question is asking for the equation of the tangent to a curve given by this expression at a particular point. So there's a particular point on the curve where x equals 0, and we need to find the equation of the tangent. Now, what's special about the tangent is that the gradient of the tangent is equal to the derivative dy by dx of the function. So the gradient of the tangent is equal to dy by dx at the point that they gave us. So the point we're given is x equals 0, so we're going to substitute x equals 0 into dy by dx. So that's something we're going to need. But also, to find the equation of a straight line, we're going to need the coordinates of the point. And we only have the x coordinate. We don't know y. So the equation of your tangent is going to look like this. The equation of the tangent is going to look like y minus y1 equals the gradient times x minus x1. Now we can get the gradient from dy by dx. We know x1 because it's given in the question, x equals 0, but we still need to find y1. And we can find y1 by substituting x equals 0 into the original expression. So let's start by finding y1. So we can say y1 equals e to the power 4x times ln x plus 1, where x is 0. So I'm going to replace these x's with 0. So I'm going to have a 0 here and a 0 here. So e to the power 0 is 1, but ln 1 is 0. So you can put that in your calculator, but you're going to have 1 times 0, which is 0. So that's our y coordinate. So that means this point here has coordinates 0, 0. Okay, so the next step is to find dy by dx. So let's try differentiating this function of x. So here it looks like we have two functions that are multiplied together. So whenever you have a product, you're going to need the product rule. And I'll remind you that the product rule, when you have y equals u times v, then the derivative of y is u dash v plus u v dash. So that's our product rule. Keep that there. Now it doesn't matter which term you choose as u or v, but I'll choose the first term to be my u and the second term to be my v. So I'll write this out. U equals e to the 4x and v equals ln x plus 1. So let me move this out of the way. So what we now want to do is to differentiate u. So the derivative of an exponential is the same, but we then multiply by the derivative of 4x. So that gives us 4 e to the 4x. Now the derivative of a ln is simply 1 over x plus 1. But then again, we use the chain rule and we multiply by the derivative of x plus 1, which is 1. So now we have u dash, v, and v dash. We can write dy by dx. So dy by dx equals, so the product rule says u dash v, so that's this multiplied by that. So it's 4e to the power 4x multiplied by ln x plus 1 plus uv dash, this multiplied by that. So it's e to the power 4x multiplied by 1 over x plus 1. Now, that is it. We don't really need to simplify it. We could, but we don't need to, because what we want to do is to find the gradient of the tangent. And the gradient of the tangent is simply dy by dx at the point x equals 0. So I can say that the gradient that I'm looking for is dy by dx at the point x equals 0. So it's simply the same expression we just wrote, but replacing every instance of x with 0. So I'll put that there, and I'll replace my x's with 0. So this power becomes 0, that power becomes 0. Okay, so again, if you put this in your calculator, that will give you a 1, that will give you a 1, that 1 over 1 will give you a 1, and that will give you a 0. So the gradient will be 1 times 0 plus 1 times 1, which is 1. So that's the gradient. So now we can write the equation of the tangent. So we know the equation of the tangent is simply the equation of a straight line with the coordinates of a point. So I'll put that there, equation of tangent. Now we just found the gradient, and we know that x1 and y1 are both 0. We've already found that, so that was given in the question, and that we calculated up here. So now we know these three things, 1, 2, 3. We can write the equation of the tangent. So we can say y minus 0 equals 1, x minus 0. So that means y equals x. And that is the equation of the tangent, and that would be your final answer. So that's how you find the equation of a tangent to a curve at a given point. You differentiate, you substitute the value of x to find the gradient, but you also substitute the value of x in the expression for y, so you have the x and y coordinates of that point, and then you put those three numbers into the equation of a straight line.